Muchas gracias, Almudena. Neurociencias, inteligencia artificial, proteínas. Qué variedad de temas estamos tocando hoy en esta segunda edición del STEM Women Congress en Madrid. Y ahora damos paso a la última talk y nos vamos al espacio con Helia Sharif, Detection Engineer-PMO en Thales Alenia Space.
Hi, everyone. I hope you don't mind, but I'm going to switch to English for this presentation. My Spanish is still in the process of developing, so maybe you'll understand me better if it's in English. So thank you for the introduction. As an aerospace engineer, for today's talk, I want to draw parallels between the challenges of launching something into space and the challenges of launching a career into STEM. So with that, I want to be more specific. So we have some takeaway home messages and experiences that I can share with you. So with that, I want to be more specific and use examples. For an example, I'm going to use James Webb Space Telescope. James Webb Space Telescope, most of you probably have heard it in the news. It was recently launched to space. It's quite popular because of all the challenges that it's gone through over the last 3 decades. And I will use myself as my experiences of an aerospace engineer to share my experiences reaching this point. But we'll talk about that experience and that video on your right side a bit more later. So I'm going to break it down into 2 main categories, the challenges that I'm talking about. The first one is technical and logistical complexities that we face. And the second one is innovation and collaboration. So for James Webb Space Telescope's case, there are a number of things that you could say it's technical and logistical. It's quite complex and cutting edge, this technology that they have launched into space, this cutting-edge, state-of-the-art space observatory. Some of them I'm listing here. You can see the deployment sequence, for example. Typically, before I go into detail, typically for space missions, launching something into space, there's a number of risk factors. But with every milestone that you accomplish, the number of risk kind of goes down. So one of the big ones that usually gets removes most of the risk is when the launch of the subject is successful, when you launch your payload and it reaches space. In JWST, so James Webb Space Telescope's case, that was not the case. They launched successfully, but it didn't remove most of those risks, or the majority of the risks. The majority of risk were some of these things. So the deployment sequence, for example. It's so complex to deploy at the high precision and at slow pace the different panels that are going to protect the instrument from the heat of the sun in space, that the smallest thing that went wrong or the smallest wrinkle that was created that was not anticipated, it could have compromised the whole mission. So after the launch, most of the risks were not removed. In my case, very first experience that I had in the space sector was my first internship, and that was with Hot on Mars project on Devon Island in the Canadian Arctic. I had the opportunity to live in this very remote location on Earth. It's the largest uninhabited island in the world, from what I've read. And it has a very interesting environment. It's harsh, but also it's very similar characteristics to what you find on Mars. So it's interesting for researchers to go there, to test their instruments, test their projects, and develop it, learn from the environment and how the things are reacting with the environment to take away and prepare themselves for the next mission, next opportunity that they can send something to Mars. So this is what it looked like when I was flying into Devon Island. I had the opportunity to go there to this remote island that is uninhabited. But because it's remote, you have to think about every logistical thing when you're going. If there's an emergency, there's opportunities to evacuate, but often you don't have that. So we had to even bring a paramedic with us on site to help us. You have a backpack, kind of like those big backpackers that go through Europe during the summertime. You have everything you need, your clothes, your gears, everything is in there. And then they're going to bring food that they bring with you during the beginning of the mission, and everybody's more or less there for the whole month in the summer, because that's when it's 24-hour daylight. We perform the test, and then we all head out. So the tent on the right side is my tent. It's where I was sleeping at night. Often my commute, or my work was setting up the antennas for the mission, for the team to be able to connect with the base camp and transmit the data. And some of the tests that we were doing, for example, was testing the spacesuits. Other days, my day was more interesting. I was on a commute to work on an ATV. It was first time learning how to ride an ATV when I was there. And we were going to sites that were more interesting or more, had different terrains, different altitude. And we were testing the pink rover here that I'm standing next to in the video. But what I want to say is that this experience of being on Hot on Mars project was the very first time that I got involved with space, and it was my first opportunity to interact with the team that was there, with the team of researchers that are in the field that I want to be in. And it was very beneficial for me. During the coffee breaks, I was trying to grab somebody, talk to them, ask about, how did you get here, try to find opportunities that we can mentor and connect. And it helped me normalize that being in this field is possible for me, and that I can achieve it, and that anybody, if they want it, can do it. But of course, there are days that we all have those difficult days ahead. Okay. The title is not Hot on Mars Project, but this is James Webb Space Telescope. The second challenge that I want to talk about is innovation and collaboration. This state-of-the-art technology that we have launched into space took nearly 3 decades, 30 years, to get to be developed and launched into space. It was so complex that not all the technologies that we needed in order to be able to launch it were existing when we started with the project. They had to develop things. The cryogenic mirrors. And for example, these mirrors that you see here, there are 18 hexagonal mirrors, and they had to be aligned perfectly with such a precision, more precise than the width of the strand of your hair. So you can imagine if it has to deploy in space, they have to do dozens of tests, research to make sure everything goes smoothly, because you only have one try. In terms of innovation and collaboration, for my experience, one of the ones that I want to talk about is the parabolic flight. So you saw the video earlier that I was spinning around. It happened in one of these planes. I wanted to perform a test during my PhD studies that I could carry out some tests and to understand how my system that I'm designing would behave in microgravity. There are very few opportunities that you can launch something to space. It's quite expensive, and it takes a long time of lots of paperwork before you can get there. But there's another way, and it's with a parabolic flight. So I don't know how many of you have heard of a parabolic flight. Oh, there are some actually, that's good. So the way it works is that it's an Airbus 300 airplane, and from Bordeaux, France, it takes off. And the pilots pull up. So for 20 seconds, it's pulling up, and you feel twice your weight on your chest. It's a 2G. And at that moment, you just have to stay still. And then for 20 seconds, you're free falling. They turn off the engines, and during those 20 seconds, we started carrying out our experiments. We were collecting data, looking at analysis, so this is our instrument that we had. And then again, they turn on the engine and try to go back into cruising altitude. And during those 20 seconds again, you feel the 2G on your chest. And they repeat this over and over and over. And you're going in a parabola. So they turn on the engine, microgravity, turn on the engine, resume. And they just keep repeating it. And you can carry out experiments like this during the flight. And I was very lucky that I had this opportunity, very fortunate, to be able to perform it over 3 different campaigns. But to get there, there was a lot of research and testing and preparation that we did. We reached the day of the launch, the day that we were going to fly with our experiment, and we're going through the final tests. And you see the technical team are doing the final test, the safety team, and they found a problem we weren't anticipating, and they said, there's a short circuit. If this happens during the flight, we're not going to be able to allow you on the flight. You have to fix it now. So we had to remove the payload, go back into the lab, and the team came together where, we have a quite different or diverse, let's say, background and expertise, and we put our heads together and said, okay, what tools do we have with us right now? What can we do to make this, put it all together? And quickly, we managed to find a creative, innovative solution that probably wouldn't have been our first choice if we had the right tools for it. And we fixed the problem right on the spot. And we were very fortunate that we made it just in time to pass the qualification test and then be able to fly with our experiment. So diversity makes a huge difference from my experience. Now, here I'm in Spain, working at one of the leaders in the industry. I'm very fortunate that since I've started working at Thales Alenia Space, I've been involved on a project called Engineer-PMO. It's a collaboration that a payload is being developed or has been developed by Thales Alenia Space and Microsoft. And we launched it about a month ago, more than a month ago, to space. I mean, when I look back on the first day that I started my engineering degree, I didn't think I would be here today. So there was a lot of obstacles and challenges that I went through. But I think with every challenge, I learned and gained a new skill, gained a new confidence, and it helped me to reach here. During the last year of working with this project, with this instrument in the lab, there were days that were long, but also we just found problems that we just thought, oh, we're not going to make it to the launch. This is not going to happen this time. They're going to cancel the project altogether. But we persevered, the team together, we came together, collaborated, tried to find solutions, find a new way to tackle the problem, and lo and behold, here I am today that I can say it was launched. So this is me in the photo, in case you were wondering, and it's a huge career milestone for me to say that I worked on an instrument that now is in space, that I get to see that it's going to come alive in a week or two probably when we start communicating with it and start collecting data. So this is the launch day on March 23rd that our project Engineer was launched with SpaceX's Falcon 9 from Florida. If there's a takeaway message that I would have for anyone who's out there, is that there is going to be obstacles along the way. You just have to persevere and push through it. But more importantly is that the importance of mentorship and networking. And when I say mentorship, I mean if you look up to someone out there, you find them interesting, you find what they're doing is interesting, just approach them, don't hesitate. Ask them if they're interested to mentor you, to have a coffee and just talk about how they reached their career. You're going to learn a lot from it. And for those of you who are not sure if you're ready to mentor, if you have enough experience to mentor, I would highly recommend you to just go for it and give it a try. Because I'm pretty sure everybody has an experience to share. And it's going to be beneficial for everybody. So there's nothing to lose and only things to gain from this experience. So I would highly, highly, highly recommend it. Now, behind every successful or every success story, there is a lot of people that have supported and gathered and encouraged it to reach that dream, to make that dream come true. In my case, in my case, I have a lot of people to thank. My family, my friends, my peers, and my mentors. So go out there, look for your mentors. I have one of my mentors and my better half also in the audience, Borja, that I'm thankful for having, because these mentors, your support net is going to help you, support you, and encourage you to reach that dream that you have, no matter how crazy it is. And I thank you all and thank them for everything that you've done.